everybody hear me? All right, well, I'm Jill Horton, and with Carly here, we're going to be going over the update to the Wiscland 2 project, which is the Wisconsin land cover map. We're about 10 months into a 2-year project, so we thought this was a good chance to get together with everybody, let you know where the project stands, some of the preliminary results from the pilot project, and where we're going to go from here. So for people who aren't familiar, I will give a quick overview and background of the Wiscland project. We're going to go very high level over some of the methodology that we're going to be using to create the maps themselves, give you an update on the pilot project results, the status of the various project steps, and then where we're going from here to finish this project up. Now, for those of you who aren't familiar, Wiscland is a statewide land cover map created using remote sensing satellite imagery. There is currently one in existence. We're going to call that Wiscland 1 here. It was released in 1999, but it's created using early 1990s satellite imagery, so it's getting around over 20 years old, so it could use an update. Starting back in around 2006, there were a variety of meetings between the UW, the DNR, some grant proposals to try to get the project updated, but none of those were successful. Then in 2012, the Deer Trustee Report came out in Wisconsin. I'm guessing there are some people in the audience who are familiar with that report. And one of the things it mentioned in there is a major barrier to deer management in Wisconsin was the lack of an up-to-date land cover map for both using for deer habitat and for deer range. So Act 20 of the budget authorized the DNR about $500,000 to update the Wiscland product. That project, which we call Wiscland 2, officially started in May of 2014. Carly and I joined in July of that year, and it's scheduled to be completed in June of 2016. And in the intervening 20 years, as you can imagine, there have been a lot of things that have changed from a technology standpoint. Geospatial data, back when Wiscland 1 was done, was you had to purchase each of the Landsat scenes. Now those are all free, open, available to the public to download off the USGS Globus server. We've also gone through some changes in the satellites and their sensor technology. We had Landsat 5, now we've got Landsat 7, Landsat 8 that launched in February of 2013, and the technological advances that have come with that change in technology. From a classification standpoint, machine learning algorithms have become more common and available, as well as some of the segmentation algorithms that can be used to classify images and do some of the post-classification cleanup. And 20 years in computers is a lifetime. They've gotten faster, they've gotten cheaper, storage has become much less expensive. All of those things help to make this project go. Who's involved in the project? There are 3 main team components. The Department of Natural Resources is the primary lead on it. They represent all the stakeholders, and they define what the product's going to look like in the end. What's the classification scheme? What's the data format going to be? All of that comes from them. And then the University of Wisconsin, through the State Cartographer's Office, is responsible for the project management and outreach, and the project team, which does all the image processing, image classification, and the map creation itself. And then there's the Science Advisory Committee, which is made up of a variety of people with different backgrounds, different organizations, and they're responsible for reviewing the methods that are going to be used and advising on that part of the project. Some of the main stakeholder needs that have been identified is, of course, deer and wildlife management is important, but also forest resource management, forest extent and habitat types, habitat modeling, conservation planning. Honestly, the uses for an updated land cover map there's numerous. And the data set itself, what it's going to look like, especially comparing it to the Wiscland 1 product, it does have some pretty distinct similarities, but some pretty big differences. It's obviously going to be statewide. It's going to be a 30-meter resolution, which is the same as what the Wiscland 1 was. Wiscland 2, though, is going to have a 2-acre minimum mapping unit, whereas Wiscland 1 had a 5-acre. And Wiscland 2 is going to be a 4-tier hierarchical classification scheme. Wiscland 1 had a 3-tier. Now, what the hierarchical scheme means is they're each going to be nested. So there's going to be 8 broad land cover types. Those are things like forest, grassland, wetland, very broad, very coarse land covers. And then within each of those, they get broken down into their more detailed levels. So for example, up here we have the forest class. Forest would be a level 1, and then within forest you have its level 2. Broader but more refined, conifer forest, broadleaf deciduous forest, mixed deciduous conifer forest. And then they get even further refined when you go down into level 3 under broadleaf deciduous, for example, oak forest. And then the most fine level of detail, for example, using the oak forest, is it's a red oak forest or it's a white oak forest. So each one gets broken down further and further. And right now, there's about 47 different land classes if you look at all of them across, going down to the highest level of detail. So how are we going to do this? We are using Landsat data. Currently, we are looking at any available imagery from 2009 all the way through 2014, as well as a variety of ancillary data sets that are potential features to be fed into the classifier. One of the things we wanted to do with Wiscland 2 is to try to harvest as much existing data as we could. Wiscland 1, part of the project was going out into the field and collecting all of the field training data that they needed to create the map. We're trying to use existing data sets as much as possible to create that training data, but we are going to have to supplement that with some field collection to round out the samples. We're going to use a top-down classification with one of those machine learning algorithms. What that means is we're going to classify the landscape at the level 1, and then within those level 1 areas, look at them, what are the level 2s in that area? So here's the forest. What part of that forest area is conifer deciduous? What part of that deciduous is oak? What part of that oak is red oak? So they'll all be nested within each other. And then after the classification is created, we're going to use some image segmentation, which if you read the keynote speaker, he mentioned the image segmentation and showed that visual, to clean it up a little. Both to make it more cartographically appealing, with some of the spurious pixels, things like that, but also to enforce that 2-acre minimum mapping that this product's going to have. What have we completed so far? We have done the data collection from collecting the Landsat imagery. There are 13 Landsat footprints that are needed to cover the entire state of Wisconsin. And we have downloaded all of the imagery from 2009 through December of 2014 that is even remotely has sections that don't have clouds in them. It's over 100 scenes per footprint. So we're talking over 1,300 Landsat scenes. We also have a variety of ancillary data sets, topography, soils, vegetation indices, all sorts of things that could possibly be used by the classifier to identify that land cover type. And then we've collected 21 individual data sources from existing projects. Most of them are from DNR projects, a lot of them smaller scale, things like land cover mapping of badger habitat or bird conservation areas, things like that. So kind of restricted geographically, but we also have some statewide forest inventory data that we've been able to collect. So we took those existing data sets and compiled them into our samples database. As you can imagine, since each of those data sets was created by a different person with a different goal in mind, with a different classification scheme, we had to do some things to kind of make them workable as a single data set for Wiscland 2. So we had to do some quality checks, remove some areas that were smaller polygons that we weren't comfortable that we could get a clean sample from, remove maybe older areas that hadn't been visited in a while, things like that. And then we had to crosswalk what that data set called its land cover and say, what would that be appropriately called for Wiscland 2? So this area had 50% sugar maple and a variety of other trees. What's the appropriate class that should be in Wiscland 2? And then since most of the data sets were polygon-based and we're using a classifier that's actually pixel-based, we had to create a process to sample from those polygons to draw individual pixels that can be used in the training. When all was said and done, we harvested almost 1 million samples from existing data sets, which is fantastic. That's a huge, potentially robust data set that all we had to do was collect the existing data sources and synthesize them. But it's not perfect. As you can imagine, there is some redundancy, some bias. Some classes we have lots and lots of samples for, some classes we have none. So for example, here's our tamarack data set. You can see over the range of where you'd expect to find tamarack in the state, we have a lot of samples. They cover most of the geographic range. This is actually one of the classes we have all, if not almost all of the samples that we need. Contrast that with cattails, where we have very few samples and they're pretty much all in the Brock Marsh. But yet the cattails, from a vegetative standpoint, should be found across the entire state. So if we want to classify that, there's going to need to be some field sampling done to actually fill out that data set. And then we have things like hay, where we have lots and lots of samples. If you look at the raw numbers, it looks like we have plenty of data. But when you look at where they are, you can see that it's really concentrated in certain areas in entire swaths of the state don't have any samples. So we had to assess, what do we need from a fieldwork standpoint? We had a target of having at least 100 samples for each class per footprint. So we looked at what we had in our existing data set, compared that, and determined, what do we need? There's not a single footprint in the state that has every sample that we need. Every footprint has some requirement to collect for some class. And then what we did is we took those needs per footprint and divided them among counties that are in those footprints, because that's more than likely how the work from a field collection standpoint is going to be distributed. Now, the amount of information and the amount of points that have to be collected per county ranges pretty significantly. We have some counties where we only need 50, 60 points across all of the classes we're looking to do, and we have other counties where there's hundreds of points, almost 800 points in one county, that are going to need to be collected if we want to classify every class that should be in that county. So to help lead that on, we developed an online field reporting tool that can be used by DNR staff or whoever is going to be doing the field collection to collect and send the data to us. Essentially what this tool lets them do is it shows the points where we already have data, because we obviously don't want someone going to the same location and collecting. That would just be redundant and would not be able to be used. It'd be a waste of time, a waste of manpower. So they can see where we've been, and then they can go, and whether they visited it in the field, or they recognize it from a photo, or they know the area, they can draw a polygon and say, I know what this vegetation is. And then fill out the form, and that'll let us identify which class in Wiscland 2 that area should be put in. That data will go off the online tool into our database. It'll go through all the quality assurance, all the subsetting, all the sampling, and those data points will then be put into our database to be used as training data for the classifier itself and round out that training data. So now Carly's going to talk a bit about the pilot project and where we're going from here.
All right. So that 100 points per footprint number that Joe had mentioned earlier is actually sort of coming out of this pilot work that we had done. So we developed a pilot study using one footprint from the northern part of the state, which is mostly forest classes, and then one footprint from the southern part of the state, which had more mixed land covers, grassland, agriculture, urban, and pretty much ran through all of the major steps of the classification for these two sites. And we learned a lot about our data, obviously, when we did this. So one of the big takeaways was that this imbalance in the samples database, so both the thematic and the geographic biases that we saw in those maps earlier, is really manifesting itself in the results. So we see, for example, in the northern test site, we might have 10,000 or tens of thousands of points for aspen, but only a handful of maple. And what's happening is those underrepresented classes are getting committed or misclassified to those overrepresented classes. So they're in turn having really low accuracy. So what we want to do to address that is to sort of attack it from both ends. So on one side, subset or subsample those overrepresented classes to get it to be a more representative sample size, and then also acquire additional data so that we have so that the underrepresented samples are more evenly distributed. But even with this imbalance and some of these holes in the methodology, we had really good results for the pilot study. So at level 1, which is the broadest, most general classes, we were achieving accuracies, overall accuracies, between 82 and 92%, and then the level 4s were in the 60s through the 80s. So as sort of a broader methodology, we're feeling really confident, so we started developing tools to expand that to classify statewide. So first off is just dealing with some of the image processing. So first we download all the Landsat data from Globus, from the USGS, and we need to do some image pre-processing. So that includes cloud masking, so masking out clouds and cloud shadow, and then also doing atmospheric correction, and then stacking all of those images together. So in some cases, maybe 1,000 bands of imagery if you're using all 100 Landsat scenes, 6 or 7 bands, vegetation indices, etc. So stacking those all together, then moving over to the samples database and iteratively and randomly subsetting those into training and testing sets, and then associating each point with a pixel in that feature stack, extracting all the data out. And then we use those feature vectors in a cross-validation routine so we can sort of automatically and right away generate accuracy metrics without having to actually produce a physical map. So we have all these routines developed and we do all this locally. But like I said, this might be 1,000 bands of data. So sort of what's coming next, what we're focusing on now is doing some feature selection. So asking, are all of those 1,000 bands necessary? And the one footprint that we're working on right now has about 150 gigabytes of spectral data. So what we're really starting to look for now is there redundancy in the stack? So that might be something like correlation between spectral bands. So for example, the green and the blue band in Landsat are highly correlated. Are both of them necessary? We might be asking questions about the time of year. Are all times during the year informative for classifying land cover, vegetation indices? We can calculate, a dozen of them. Are they all useful? Which ones are useful? Missing data is a big thing, because like Joe said, we just downloaded all imagery. If it has not 100% cloud covered, well, there might be a threshold that we can use to weed out some of these more cloud covered areas. And then soils topography, are there other data sets that we should be including in the future data that we're not? And sort of as a part of this feature selection process, we can start beginning our classification runs, and that's how, partially how we actually conduct the feature selection. So again, taking this top-down approach and aiming to classify level 1 statewide first. And even though we're classifying statewide, we're still running the classifications per Landsat scene. So we take the Landsat scene, we take the associated sample data, and develop independent classifiers for each scene. And we're just simply starting with the footprints that have the most data right now, because the next thing sort of coming up is field collection season. So this should be starting soon, but really the meat of it's going to happen during the summer months of this year. And this is a DNR-led effort, so field crews are going to be going out and they're going to be guided by the field requests and recommendations that we've made based on our samples database assessment, and then reporting again back to us through that field reporting tool that some folks at the SCO have developed. And then while they're doing that, we have sort of an opportunity to finalize some of the processing workflow that is going to happen later. So we've done all this pre-processing work, and again, we're doing this cross-validation locally, but that doesn't produce a map. And eventually, we're going to want to produce a map. So once we're happy with our feature data and all of our sample points, and we're getting accuracy metrics that we're comfortable with, we want to be producing a map. And I guess the thing that I really wanted to point out here is that we are able to take advantage of the Center for High Throughput Computing, which is through the Wisconsin Institutes for Discovery, through the UW. So actually, anyone affiliated with the UW has access to this. It's free, it's awesome, and it's exactly what it sounds like. It's a center that specializes in high throughput computing. So really just taking any computationally intensive process, chunking it up, and then sending it to whatever of the thousands of different multi-core machines they have available at the time, sending it back and piecing it all together. So really perfect for some of this image processing. So again, the cross-validation and actually training the classifiers will have to happen locally, but the map generation can really be sped up by using this resource. And then lastly, like Joe has mentioned already, we're doing a pixel-based classification. So the results, we're getting a label at each pixel, and really we can use some more object-oriented approaches to refine some of these outputs. So using segmentation as a post-processing technique instead of a classification technique, and we're still testing out some of the segmentation algorithms that we're going to potentially be using. And that's really all of the image processing. So the last thing is the delivery. And the main deliverable will be map, and it will look very similar to what Wiscland 1 looks like. A single file, 4 different levels of detail for each classification scheme, and then, of course, the associated metadata and the user's guide, and there will also be a final report, which details our final methods and then an independent accuracy assessment. And all of this should be delivered by June 30th of next year. So obviously we had to leave out some details. There's lots more minutiae we could get into, but if you have questions at any point, approach Joe or I, or else check out the SCO project website, which has links to the project, or the pilot project report. It has irregular updates, mailing lists, stuff like that. And then some other UW contacts that have a wealth of information about this project. And thank yous to the DNR guidance team and the Science Advisory Committee who've been instrumental in developing this project. Thank you.
Maybe a minute for 1 or 2 questions.
Yeah, is one of the goals of this to help inform the digital wetland mapping? Because the digital part is really incomplete, or is it kind of both ways? You know, you're using what's existing and then maybe be able to fill in the gaps on their end?
Yeah, precisely. We are using the wetlands, the Wisconsin Wetlands Inventory for training data, and there are a few holes in, I think there's maybe 4 counties. There's 3 or 4 counties that don't have their data digitized yet. I think it's part of the hope that digital information will be made available during the duration of this project. But also, I think you're right to sort of, if that doesn't happen, hopefully the wetland categories, there's a lot of overlap between the classification schemes, so hopefully this can help too.
All right, we'll do one more quick question, and then you guys can track them down later. So we got one more right here.
Will this be available on the DNR website afterwards when you're done with the land classifying and be able to get down to the border section with it?
Sorry. The DNR is going to be responsible for however it's finally distributed. And Wiscland 1 is on their public FTP site, so I anticipate they're going to do something similar with the Wiscland 2 product. But we haven't really talked about the dissemination.
And also, do you know if they're going to be putting on like managed forest process and also MSL and forest cropland, like conservancy programs?
Well, the Wiscland product itself is just going to be the land cover.
Yeah.
So it's not going to have subdivisions of this forest is managed forest land or this land is public land or anything like that. Although they do have some of those available on their FTPs for the separate layers. But this is just solely going to be what's the land cover, not land use, not land ownership, anything like that.
All right, thank you very much.